right. Well, thank you everyone for coming today. I know we're getting towards the end of a long conference and you start getting really tired. And originally this talk was going to be ops in the serverless paradigm, and then there was like 30,000 other talks on that. So we were all at the bar on Wednesday night, and I decided to redo my entire talk. So you're getting a little bit more fun of a talk, and instead of just ops, I'm not going to beat a dead horse. We're going to talk about two really new technologies and putting them together, and that is serverless and GraphQL. So why am I qualified at all to speak about this? I'm the director of DevOps at Trek 10. We've been really working on AWS for a few years, and we're an advanced consulting partner. But more importantly, we've actually cut over into building serverless applications at scale. We have some enterprise deployments of serverless applications in media management and IoT. And then we've actually also built some GraphQL serverless stuff. If at any point you get angry during the talk or you want to complain, there's my Twitter. So just feel free to do it there. And I'll just ignore you here. So without further ado, what is GraphQL? So if you're not familiar with it, GraphQL is a Facebook technology. They have been using it internally for about 4 years. They released it publicly in January of 2015. So it's actually even newer than AWS Lambda in terms of open source and being out there. So really what it is this query language that you can use to define how you request things from an API and how you write data to an API. So it's that language and that definition. And then also, there's a runtime for executing those queries on your server or serverless. But there's a runtime for executing those queries. So why would you even look at GraphQL as a solution? Some of the cool parts about it is, instead of a typical RESTful interface where each of your resources has a defined endpoint /user /some ID or things like that, you just have one endpoint for your API, so /graph or /endpoint or something like that. And all of your API requests go through that single endpoint for the most part. It can provide really this easy to understand aggregated API layer on top of many resources, right? So instead of having your developers having to hit multiple endpoints for various resources, users or blog posts or things like that, you just have this one unified endpoint that you can go to and get everything from. So why that's important is that it offers some optimizations, and it makes it easier to write queries that are more optimized for network traffic and things like that. In addition, you only get the data you ask for, right? So the way the language works is I can say something like, I want a user, and I want their first name and last name and their user ID or something like that. I can get that back, and I would not get if, in a typical RESTful interface, if I would do that, I might get something like the user's avatar, all of their metadata, other things like that. And you might not necessarily need all that information. So GraphQL makes it so you only get exactly what you asked for in the same shape that you asked for it. We'll go over that more a little bit later, but that's one of the really powerful aspects of it. In addition, as you build your GraphQL endpoint, right? So you have this idea of really streamlined API iteration. You can iterate very, very quickly as you're building out this endpoint without too much fear of breaking things that people are depending on, right? So you're not necessarily, if you're adding or removing properties, typically you don't want to remove them, but if you're adding more properties or adding more functionality, you're not going to break backwards compatibility with people that were already asking for certain things, because GraphQL will take care of making sure they still get back exactly what they expected and not anything more. It's also fairly easy to extend your endpoint once you've built it, and we'll look at that a little bit more later. And then also, pretty similar to how serverless has grown, GraphQL has gained a lot of popularity very quickly. There's some fantastic tooling and community around it. GitHub recently announced and released a GraphQL API interface. So really, it's gaining a lot of traction, and we've actually had enterprises come to us and say, forget REST, let's do this GraphQL thing. We're doing serverless anyways, right? So some technical details on it really quick before we get too far. It's a typed API with schema definitions. We'll get into that a little bit more. Some of the terminology, so a query is a read. You can define multiple queries in a single request to your endpoint. a mutation is a write. So you have queries and mutations are the two big things. You can only do one mutation per request, but you can do multiple queries per request. The way the endpoint works in this execution engine is that when you pass in your query, and we'll look at one in a little bit, but when you pass it in, essentially the graph is walked by the execution engine, and it runs each of the nodes of the graph through resolvers. And resolvers are how you say, OK, take this particular query, and this is exactly how you go fetch that data from whatever source that data should come from. And then more importantly, it solves the n+1 problem. So in a typical RESTful interface, if you ask for instance, a blog post, right? You ask for a blog post in the REST API, and it comes back with a list of comment IDs. Now, if you don't have a batch get comments as part of your API, you have the typical resource defined as blog ID, right? You have your blog ID, you get back that, you get back your list of comments, and then you have to go ask for each of the comment resources as well at its URL defined resource, right? So if you have one blog post that has 10 comments, that's 11 requests. That's probably a bad example because comments you would typically have some batch get. But it elegantly solves that n+1 problem because you can do that with GraphQL with just one request without too much extra work. So to really understand GraphQL, we have to dive a little bit into what a schema looks like. And I took the example of something that kind of runs throughout this talk. We're going to talk through as the Serverless conference has speakers and talks, right? So this is how you would define it. You have this idea of a type of speaker, right? So the speaker is a resource that you can request against this GraphQL API. A speaker has a first name, a last name, and a list of talks. And the list of talks are of a custom type talk, right? So there is some basic element types defined by GraphQL. You have strings, integers, booleans, things like that. That's all normally defined. The exclamation point at the end says whether it's nullable or not. In terms of when something comes back, it might be null, so you should expect that it can be treated as a null, because that just means it didn't exist when you asked for it. So this said, we have the speaker type, has a list of talks, right? And then you have talks, or a talk type, which has a list of speakers, and then a start time, and then maybe not an end time. We'll see how long this talk goes. We might not have one. Title, it's going to be in a room, right? So you have that, and that's just your definition of your schema types, right? And Facebook has, in their 4-year-old GraphQL implementation, they said they have something like 10,000 different types and things that they can ask for on it. So it scales really quite well. And then right here on the right-hand side, I have query definitions, right? So these are the root queries. So this would be, you could actually go to the GraphQL API and ask for a list of speakers or a list of talks, or you could get a speaker by a specific ID. And then it says, like, so if you ask for speakers, it returns a list of speakers. And you can pass in an argument that says how many of those speakers you would actually like to fetch. And we'll look at why this is important later. If you really want to, there is a GraphQL schema cheat sheet that you could just go Google and find. It gives a better overview. I didn't even talk about mutations or anything like that. We're not going to talk about those much today. But really, they look about the same. It just says people can pass in a particular type of object as an argument to a mutation. So from there, once you have the schema defined and you know what kind of queries you can do, and you have your root queries, you have to define resolvers, right? So resolvers are how you fetch your data from your actual services that are providing that data, whether it's coming from RDS instance or DynamoDB or things like that. Really, GraphQL doesn't care about that. It should not care about that. But the most important thing is, so you have your query root that we talked about, right? So you have the type root there and those root queries. And then, so you have the query root, which says, OK, this is how you find all of the talks. This is how you find all the speakers. You go to the speaker service. The important thing to realize about GraphQL is that you only have to define resolvers for the more complex types, right? So when I'm asking for a speaker type, you have down here, you have the speaker type. The only complex type, if we go back to our schema is the speakers, right? Everything else is fairly basic. So GraphQL will just pass that through, and you can ask for it, and it knows how to handle that. But for the more complex types, we have to figure out how do we resolve that, right? So in our example of the blog post, for instance, you ask for the blog post, but you need to resolve comments. So inside of your blog post resolver, for the comments field, you would have something like a comment service that takes the root object and looks at the comment IDs and goes and fetches those from your comment service and sends them back to the resolver. It's not as complicated as it sounds, and once you start writing things out, it starts making a lot more sense. But really, the power here, and it's something that we're going to go into later, is that once you write a resolver in one place, no matter how deep in the graph it ends up going, it ends up working. So we'll look at kind of some more complex queries and why this ends up being really powerful. So I want to be really clear, and this is kind of a point of contention where people don't like GraphQL, and usually it's because they've ended up doing something very wrong. But it is not a business logic layer. All of your business logic should be not in GraphQL. GraphQL is nothing but a very, very thin wrapper around your actual endpoints and business logic, right? So we have a fairly complicated project that we've built that has literally like maybe 200 lines of code that have anything to do with GraphQL. Everything else is actual business logic that if we wanted to abstract to a REST API, we would just have to put Express or some other kind of server in front of it, and you'd be good to go. All of that business logic is outside of GraphQL. Another important part that I've kind of mentioned before is that you can map to multiple data sources with GraphQL, right? So you can actually use GraphQL in front of a REST API or a database or Firebase or an S3 file store, and you can actually use it in front of all of them at the same time. And we're going to go through some pretty cool use cases with that. But it's important to realize that GraphQL is not some like magical API in a box. It doesn't really care what's behind it. It's just this thin layer. So I've gone over the developer experience a little bit, but really it's important that you get exactly what you asked for and you get it in the exact same shape that you asked for. We're going to go over a little demo to show what I mean by that. And then I mentioned before, but say you have a mobile app and you have a web app, they might ask for different data in different ways, right? GraphQL doesn't care. And then more importantly, GraphQL doesn't necessarily care about if you're asking for something that was built at a different time than something else, right? So versioning is not a large concern. If you have really major changes and you're pulling out whole resources, yeah, then you have some versioning problems. But if you're just adding and iterating on properties and things like that, you really don't need to worry about versioning. And then also I've mentioned it's easy to write really efficient network requests. Facebook has actually taken that to a whole new level. They have something called Relay, which, if you're familiar with React or other component-based front-end systems, all of these components could ask for all sorts of different things. You bubble it up to the top and then send off one giant request and get back all of the data in one network request and bubble it back down to your components. That way you're not making it some kind of like typical RESTful API. You would be hitting the API a bunch of times. Instead, you just hit it once. So one of the most powerful parts about this, and one thing that our clients really love and we really love, is this idea of introspection. So you can actually do some introspection on your API and explore it, and that's because it's a typed system. So there's something called GraphQL, which is a tool that Facebook built. And we'll jack up the size here a little bit. But so if you're not familiar with it, there's an API out there called the Star Wars API or SWAPI. Facebook, it's actually a RESTful API. So there's a REST API for Star Wars. But Facebook, as a demo of GraphQL, wrapped the RESTful API in GraphQL. So when I mentioned that there's docs and you can do introspection on docs, this is what I mean, right? So this is all generated based on the schema that's defined, and you can do the introspection. So you can find out all of the available queries. Right, so for instance, I've written one just as a demo here that says, find all of the films and get the title for all of the films, right? And when I said you get things back in the exact same shape, you can see I get all films, and then the edges, and then the node, and then the title. It's exactly the way I asked for it. If I drill into all the films, I can see that there's a films connection type. I will point out that they've written this to be relay compatible, so your API might be a little bit simpler if you don't need all of the relay stuff, which is why they have edges and nodes and things like that. It helps with pagination. But you'll see, so if I have the film connection, I can ask for films, and I can see I can ask for the title or director or producers of each film. But one of the really cool things that we like about GraphQL, and GraphQL is 3 lines of code to essentially ship your actual API. You can put this with 3 lines of code and give, if you have a GraphQL API, give developers on your platform GraphQL that has all of these features out of the box in like 3 lines of code. It takes like 10 minutes. But let's say we want to get the characters in each movie, right? So I can say, give me the character connection, and you can see it can autocomplete. If we need the edges, node, and then we can get the name or the weight, the birth date or birth year of each of those characters, and I can run that query, and you'll see I just get that stuff back, right? So if I decide I want to add some new stuff to a view in my mobile app or web app, I just change my query right there, and I didn't have to go make extra API calls or rewrap the API. I just get it all right there. So that's a really, really whirlwind brief intro into GraphQL. If you have questions later, you can ask. So now serverless. Normally, if I was giving this talk, we would not be at a serverless conference. So quite frankly, if you're not sold on serverless yet, you probably wasted like your time, your money, and whatever I say on this slide just doesn't matter at this point. So with that said, serverless GraphQL, right? Because putting 2 good things together has never gone wrong, like putting a touch screen on your keyboard. That never goes wrong. So we all know the benefits of serverless at this point. You get all the big wins of serverless if you do this kind of thing. You get the scalability, availability, all that good stuff. You also, if you put it together, presumably get all of the power of GraphQL. But that said, if you were to put GraphQL on an auto-scaling group or an EC2 instance, there's actually some really interesting new things that happen if you were to take that kind of approach with GraphQL. There's something called resource exhaustion attacks. We'll go over that a little bit later. But some of those problems are actually mitigated by using a serverless approach. And then also something that we've called complex resolvers, which is a way of mapping to resources in a really efficient way inside of your Lambdas or your functions as a service platform. And we'll go through that kind of architecture as well. But really, going to that approach opens up some new, just some new ways of thinking about and handling things. So really quick, when you're building GraphQL solutions, or really any solutions, your functions as a service provider, whether it's Lambda or Google Cloud functions or Azure, it should be irrelevant. Really, it should be irrelevant for when you're in GraphQL, unless you're doing some of the complex resolver stuff. But if your developers have to worry about that abstraction when they're developing stuff, it's just a nightmare scenario. So really, we actually, in development, run an express server. That would be the fire alarm? Yeah.
Attention.
Do not panic.
The fire alarm is about to be tested. Please take no action. Attention, please.
Oh, boy.
The fire alarm is about to be tested. Please take no action.
We'll see how bad this thing is. All right, so I'm just going to keep going. So your developers, so for instance, we actually run GraphQL inside of an express server for local developers, so when they're working on it, and then we just rewrap it when we deploy it. And there is no thought at all to whether it's in Lambda or on a server or anything. It literally does not matter.
Attention, please. Attention, please. We are investigating an alarm condition. It may be necessary to evacuate the building. Please await further announcements.
I'm glad we knew about it at least, right? That would have been worse.
Attention, please. Attention, please. We are investigating an alarm condition. It may be necessary to evacuate the building. Please await further announcements.
This is why you don't test in production. So testing can really be, for your GraphQL and kind of your integration testing, you can just throw actual GraphQL requests, queries at your system. And it's really literally data in, data out, right? So event in, data out. And you can just do some really quick checks on it. And that's a really good high-level test.
Attention, please. Attention, please. The fire alarm test is now complete.
That's a pretty crap fire alarm.
Attention, please. Attention, please. The fire alarm test is now complete. Please
all right.
respond to all future fire alarms.
No problem.
Are you quite sure you're done?
All right, so and then one more thing. I'm sure some of you have heard of, if you're using JavaScript, there's Flow or TypeScript. They can usually relate to having like a lot less self-hatred at the end of the day. We've really found that. That said, if you're building a fairly small API and it's not going to grow and it's not going to be the core business value, just ignore Flow or TypeScript because you'll hate yourself more for implementing them at that point. But really, they can be really powerful, particularly when using GraphQL and having all of the types properly type checked and things like that. So I mentioned this idea of complex resolvers. This is one of the most powerful things that we've really seen in terms of GraphQL and resolvers and fetching data, right? So there's this idea that your GraphQL endpoint, it's this light wrapper around your other services. You might have legacy services behind REST APIs. You might have stuff in an RDS instance that's behind another service. You might have stuff in DynamoDB, right? So there's this idea where your one Lambda function can actually invoke other Lambda functions. And what can happen is that instead of one particular server trying to run or one particular Lambda function trying to hit a DynamoDB, an RDS, and a REST API, you can actually, inside of your resolvers, which is, if we go back to this particular code, right? Each of these, for instance, this could hit a DynamoDB. Our talk service hits a DynamoDB. Maybe our speakers are pulling from LinkedIn, so that actually executes out into another Lambda function, and that hits LinkedIn. And it's this really powerful idea where if you're splitting all of these out, you get more resources, and you can execute faster if you spin things out to other Lambda functions, if you do it properly, right? So the complex resolvers is actually a fairly large win in some cases, especially if you're hitting a lot of legacy stuff, right? You can just wrap all of this old legacy stuff behind GraphQL, and now your developers just get to leverage it like they would anything else. The other important thing is that GraphQL handles all of the aggregation between those. So, for instance, if we are pulling our speakers from a REST API and we're pulling the talks from a Dynamo database, the developer just doesn't care when they're, in terms of interacting with other pieces of data. They just have to return exactly what they were asked for. They don't have to worry about how is this going to aggregate. GraphQL will take care of all of that aggregation. And then the consumer of that API really doesn't care what's going on behind the scenes. So that's one of the interesting things. Now, I did talk about some problems, right? So with GraphQL, there's this idea of resource exhaustion attacks. You can really think about it as like a denial of service attack, except it's really easy to do against yourself if you do it wrong, which is a really bad idea. So to really understand how that could happen, there's this idea of deeply nested attacks. So we'll go look at it and see if it works. But you see right here, so we're asking for all of the Star Wars films, and then we're asking for all of the characters of each film, but then we're actually asking for all of the films that each character was in all of the films, right? So we get back all of the data like we expect. However, if someone was malicious and or stupid, they might do something like say, well, I have all of the films for each character for all of the films, but now I want to know, for instance, all of the characters in each film of all of the characters of all the films, right? So I could do something like this and ask for all of the names of all of the characters in each film for each character for all of the films. And you'll see it actually takes quite a while, right? I'm sure Facebook hates it when I play with this, but and you can just keep doing that. And you can just keep going and going and going and going. And there's nothing really to stop that natively. So what happens is you can actually consume gigabytes of RAM and like completely blow out a CPU by just asking for something wrong. Or if your app is aggregating all of those requests up and they're improperly aggregated, you could really hurt something. So that could really take out a server. But if you think about it, there's a couple ways you can get around it, right? So there's some useful optimization and prevention techniques. One you can do is just maximum depth check and say, oh, if the depth is more than 5 deep, I'm just never going to run it. It's never even going to hit my engine. Just throw it out, right? That's a pretty naive way of doing it because there might be valid use cases for going fairly deep. The other thing you can do is for each kind of resolver or resource that's asked for, you can assign a score value or some kind of weight value. And if the overall score of the query or the weight of the query exceeds some threshold, you throw it out. And then there's also a useful optimization around request batching and caching. We'll look at that later. But that can help as well. And honestly, you can tell Facebook's not using it. But there's some interesting things there. So if you use serverless, there's actually an easy way around a lot of this. So each execution of your engine is running in a Lambda, which has its own resources. So you can assume that any given execution will not impact other executions, right? So if you run with that assumption, we can do something really easy and just set a timeout on the function. So if all of your valid executions of your GraphQL should happen within 3 seconds, if we set double that, 6 seconds, and say, if a query has not finished in 6 seconds, you are doing something really bad, and we're just going to throw you out, right? That's like a 98% solution to most of this, and it's the easy one, and it's the cheap way out, and honestly, we take it like half the time. Because it's much easier than trying to assign weights and all of that stuff. So really, serverless helps you around kind of a pretty big weak point in GraphQL on servers. You still have people that could honestly hammer you from an IP address or things like that, and you can just put a web application firewall in, parse logs and look for those IP addresses and then just block them, right? So you still have some problems there if someone's really trying to attack you, but doing a reasonable timeout and reasonable resource allocation on your functions is a really good first step. So one of the most important things that we've run into is request batching and caching, right? So you still have this n+1 problem to some extent where maybe your client is not doing the n+1 request, but your server might end up doing it, right? So we have 42 speakers and 38 talks here at this conference. There is one speaker that has multiple talks, and then there is multiple talks that have 2 speakers. So what ends up happening is you can add some caching that says, all right, for every time I'm going to fetch a resource, I'm going to check and see if in this execution I've already fetched that resource before, right? So we might ask for a talk once, and then for another speaker, we ask for that talk again. We don't need to refetch it over the network. We have it locally. So you'll see if you just do this naively, you have 43 requests. One request gets all of the speakers, and then you have to get all 40. You have to get the talks for each particular speaker, which is there's 42 speakers, so you do 43 requests. That's fairly inefficient, right? So we implement caching, just naive caching. And we say, if we've already fetched something, we don't have to fetch it again. That only gets you down to actually 39 requests because there's only, 4 instances, I think. There's only 4 instances where a talk is actually reused across speakers. And then there's batching. Once you add batching into things, that's where things really start flying. And batching is the idea of, I'm going to ask for 38 talks, right? Instead of doing 38 requests to ask for that, I batch those all up into one multi-get, and I just issue that. So I ask for all the speakers, and then as the engine is parsing and it figures out it needs to ask for these 38 talks, you can do some magic in the Node.js or whatever event loop you're looking at, batch those all up, and send those out as one more request, and it comes back, and so you're down to 2 requests. That's a really powerful paradigm. The important part is, though, that's really hard to get right, and your developers will not get it right. So you have to abstract the entire idea of cache and batching away from your developers. Your developers should just be able to use your services and or however you're fetching things as they normally would. They should just say fetch single thing from this service, and your service that is actually, or your objects that are doing that fetching should take care of sticking things in the queue and running through the event loop. And making sure that they are doing the batching, and then when it comes back, they distribute it back to whoever requested it as if they only asked for that one thing. Facebook has something called Data Loader, and it is a fantastic tool if you're using Node.js. I highly recommend it because it makes all of this much easier to the extent that you really just, it's almost like magic, quite frankly. One other cool pattern that we've seen is isomorphic rendering or server-side rendering. So if you're building front-end applications and you want to render HTML, so for SEO purposes or caching purposes or things like that, right? If you have a React.js-based blog, the last thing you want to do is like load JavaScript and then hit an API and then load in your stuff. That can be slow, and Google might not like it. Google's better at it now than they were. Other search engines might not like it, and it's just fairly inefficient. So one thing you can do is run your server-side rendering inside of a Lambda function. And if you do that, you can actually return through API Gateway, return the HTML, cache it in CloudFront or your CDN. But the important thing to realize is that if you do that, you should not try to invoke your API directly from the HTML rendering Lambda function through another API gateway to your GraphQL. You can just directly invoke your GraphQL Lambda function or whatever other function you're doing and just pass in the event that it would expect as normal through API gateway, so you can skip an entire, basically, loop of latency. So that's one trick we've learned that has really it saves a lot of time and, quite frankly, cost, right? Because API gateways can be expensive. I do want to raise the fact that there's probably people in this room and on Twitter for a fact that GraphQL is not a magic bullet, and I never said it was, right? There's still a lot of really hard stuff in it. Authorization is not a solved problem, right? There's some approaches to it where really your authorization for fetching resources should be at the resource level, and it checks when the person is requesting it, it checks that they're actually able to request that resource, and it's not in your GraphQL layer, right? No business logic at all should be in your GraphQL layer. Pagination is hard. You can do that with tokens. Facebook, with their relay library, has tried to solve some of this. We've also cheated at times and just mapped through like a DynamoDB token. When you do a request against Dynamo, like a scan or something like that, or a query, you get a token back if you're not at the end. So we can just pass that back through the GraphQL API, and then someone, when they're asking for the next page of data, would just pass that token back to us, and we can just cheat and pass that on to DynamoDB, right? Just don't even write your own pagination system. Use what somebody else did. Good documentation. So we saw the documentation available provided by GraphQL as a result of the type schema, but it's not the greatest in the world, and it's not very good at explaining what's going on. So you still have to write good docs, especially if people are consuming this external to your company, and that's an important value add that you should do if you're doing that kind of thing. And then more importantly, and I think this applies to serverless architectures in general, you're really only as strong as your weakest resources that you're depending on, right? So if I write GraphQL on top of this garbage legacy system, it doesn't matter how scalable my GraphQL API is if the system behind it can only take 5 requests a second, right? It's going to fall over the second they exceed that. So that's one really key point to understand, and you might have to do some things with queues or things like that if you're really hammering those legacy systems, but you're only as strong as your weakest resources. I have a getting started slide on here. I'm going to post these slides up and blast it out on Twitter, and I don't know if the Serverlessconf guys are organizing anything to get slides out. But there's a few really good talks. There's one on YouTube from Dan Schaefer, the guy that created GraphQL, where he actually goes into pagination and authorization in depth and really explains how they handle it at Facebook. There's something called the Apollo Stack, which offers a lot of clients and tooling around GraphQL. That's fantastic. The cheat sheet. And then also the serverless framework guys have a serverless GraphQL boilerplate starter kit. That's fairly well thought out, and you should take a look at it if you're considering this. So that's my talk. I think I have a couple minutes here, about 4, 5. So we could do some questions if anybody has any.
Yeah, and also slides are going to be out next week with the videos, just so everyone knows.
Can you go into a bit more detail around the business logic separation? Where does that go?
Yeah, so typically what I would say is that this is really like the main GraphQL, right? So this is saying, this is how you resolve when people have asked for things. Your actual business logic could go in a couple places. If you're consuming other resources, if you're consuming some other REST API or some other internal service, arguably your business logic should all be at that level, and GraphQL should just act like a router to those services, right? Take the request in, figure out what I need to ask for it from that given service. If you're writing it as an application level thing, and GraphQL is like a mapper on top of the application that you've written, but they're still in the same directory or something like that, right? Your business logic would go at the class level or however you're asking for it. So for instance, the speaker service here might check to see, we've passed it the context, so the user that's asking for things, and we've passed it the speaker IDs. So that particular service could ask and say, okay, is this person allowed to look at these speakers, right, as they ask for it. So really, GraphQL is just, you can think of it almost as like a router to your additional services. And the business logic is in those services, nothing to do with GraphQL. GraphQL just passes through, if you think about it, GraphQL would pass through like a JWT or something like that to those services. That's a good question. So typically you don't rename things because if people are already depending on it, you would break them, right? But you can fairly safely just change any properties or add new properties or types without any kind of risk. And I do want to be clear, it doesn't imply a data model. So the GraphQL schema has nothing to do with your data model. The GraphQL schema only defines exactly what and how something can be asked for. It has nothing to do with your data model.
Not like best practice for authorization yet in GraphQL. So may I ask how you currently solved it?
So we just take in JWTs, and quite frankly, we just pass it through to the services as they're written, right? So that business logic level and GraphQL there. We do one thing where we've actually distinctly created a public endpoint and then an authorized endpoint. The authorized endpoint just checks that the JWT is valid, and then it will pass it through to the additional services. The public endpoint doesn't care about authorization. Does that answer the question?
Yeah.
Okay.
Thanks.
Other user cases in which this type of like using GraphQL and serverless would be a really good kind of application?
At what level? Like, what do you mean?
At what level?
So, are you saying like more like architecture type of patterns, or?
Yeah,
like,
well, I mean, or even when one of the examples you used was how like, oh, this could be really good for isomorphic like server-side rendering. Like that's really cool.
Yeah.
That's actually like really good.
Yeah.
And in terms of like helping, yeah. So I'm just saying, is there other type of that? I mean.
Yeah, that's a good question. I don't really have a.
That's kind of like a win, you know. So I can go to
Yeah.
and be like, look, this is what we can do.
Yeah, the biggest win we've seen from companies and organizations is that really mapping against legacy data sources and saying, look, keep it as it is, but I can build something new on top of it and merge it with all of our other data sources without you having to rebuild any kind of bridge or anything from those legacy data sources. But in terms of other architecture like SSR or the complex resolvers, I can't think of anything magical that we've done on top of that. I think this is the last question then.
So I'm in this moment in time doing basically the same. So I'm building my Lambda function to actually get a graphical server. The thing is, I don't know how it will scale in terms of complexity in the next few months, let's say. Do you have any advice? Do you have any feedback about that? Your experience?
Yeah, so my biggest advice would be GraphQL is a super thin wrapper on top of whatever it is you're building, right? It should not, your GraphQL file might get larger as you have new types and things like that, but your types and resolving those types should never exceed like 1 or 2 lines of code inside of your GraphQL resolvers, right? Keeping that as thin as possible is the easiest way to do it. And logically, like for instance, in our talk service and our speaker service, like they are 2 very logically separated things. I could pull those out and put them behind a REST API if I wanted to, right? So the key is really GraphQL it's just this wrapper that makes it easier for developers to query and mutate against your services behind that. Yeah, I don't really have a better answer than just keep GraphQL light. It should not be this big thing.
Thank you. All right, we are out of time, so now it's a 20-minute break, and then lightning talks in the function as a service room on the other side. Thank you very much, Jared.